Welcome to our next podcast series. I'm here with Ilker, Chief Engineer at AVL for Electrification. I'm Stephan Tarnutzer. I'm responsible for AVL Mobility Technologies in the US. We're talking today with Ilker about electrification.
Yep.
That's where his passion is. That's what he does for us. That's what he's really good at. And maybe starting out with the first question, most important power electronics technology to advance EVs? Is it silicon carbide? Is it what everybody's talking about now, 800 volt systems instead of 400 volt systems? Is it what? Your opinion?
Thanks for having me today. So basically all of the things you said. So it's right that you're hearing more and more about these, like 800 volt, silicon carbide. Yeah, that's all becoming part of the products or vehicles that our customers work on. And why? Because I think it dates back to like in the 5-10 years. They were like kind of an area that people used to explore. Then the company came and said that, no, we are going to adapt it. That's the Tesla. And then they said that they saw that, it's actually working. So more and more, let's say, effort went in. And now it's becoming like the state of the art. Like whenever I talk to our customers, the conversation always starts with, okay, we would like to have silicon carbide switch in it. What should we do? What's the aspect of it? Then the conversation goes on like we kind of help them decide that what it takes to adapt those new technologies, 800 volt silicon carbide. And so, switching technology is one thing, and this higher voltage. Why higher voltage? I think it's also being driven by the power requirements at powertrain level. So more and more we see cars that has like 150 kilowatts of traction power. That wasn't the case. So I remember we were just fine driving like 50 kilowatt engines, right? And now we just would like to drive like 150 kilowatt cars. So that, moving to that higher power level comes with some challenges. And higher voltage is just one answer to that, to overcome those challenges.
I hear sometimes people talk about an inverter. Again, silicon carbide, certainly switching frequency and ability, right, is important there. But I sometimes hear them talk about it's just an inverter, let's put it that way. Software, it has software, but it's not that important. Do you agree with that?
No, not at all. So, yes, by the way, to elaborate on this silicon carbide a little bit more. So silicon carbide is going into all high power electronics. So it's inverter, it's DC, onboard charger. So it has a lot of, let's say, areas regarding the inverter. So inverter is maybe for most of the people is like a black box. You just put it, drives the motor.
It's a big deal, right?
Yeah, people are more interested in what comes out of the shaft. Because that's what moves the vehicle, right? So if you cannot move the vehicle, then it doesn't become like a vehicle. So there's a lot going on in inverters. In fact, for example, the range of the vehicle is, it's heavily influenced by how you operate the inverter. And
with operation, you mean the software that drives it, right?
Exactly. Yeah. And right now, I think it's more and more becoming like hardware and software going hand in hand. So it used to be like some off-the-shelf third party bringing you a kind of a piece of hardware. You just try to integrate it, not anymore. So looking at the recent projects that we do with our customers, inverter, all these e-motor as well, and the other components is no longer like a kind of a box that you put on top of the other boxes. It is fully integrated. What I mean, for example, think of an e-axle. When you look at the e-axle of a recent EV, you will have a difficulty to point out where the inverter is, where the e-machine is. Like the trend is like having all of them in the same package.
The 3-in-1, as we call it, right?
Exactly, 3-in-1. So the e-machine, inverter, gearbox, all in the same housing, and you can no longer kind of separate one from each other. And it's why I say that the hardware and software development goes together. And when you look at the power of software, yeah, I think that's where you start to differentiate yourself from the rest of the competition. So we know that software has been eating the automotive for quite a long time, and there has been a lot of changes, right? So software is as part of it, like this. I think there's a lot of kind of push to get like additional functionality, additional efficiency, additional, let's say, safety measures through software. Yep. Because there's always a kind of a maybe limitation that you can achieve with the hardware, or there are some of the kind of the things that you would like to have, but that software becomes the enabler of those. Yep. So yeah, there's a lot going on, in the automotive that I can say that's changing a lot, the way we do things, the expected things that we implement in the systems.
Yeah. When it comes to you and your work that you're doing, what are your customers? What do you believe your customers are not paying enough attention to when it comes to power electronics? Is it I'm thinking of, is it the design of it? Is it the software? Is it the functional safety behind it? Maybe cybersecurity? Is it the validation, simulation, the flexibility of designing an inverter or an e-motor, not just for one application, but already with multiple applications in mind? What is it, maybe the top one or two that you feel like your customers are not paying enough attention to?
So power electronics is definitely an area that maybe most of our customers do not have an in-house established know-how and experience for a long time. Okay. That's okay. That's understandable because power electronics became like a more dominant factor with the EVs. So since our customers are quite familiar with the conventional vehicle development, and they're trying to kind of phase into this new era, like having let's say a product portfolio with more EVs in it. So power electronics become like an area where either they don't have the established know-how, maybe they're just stepping into it, and when you think of this area that you don't know much, I kind of see that people tend to oversimplify the challenges. Okay. So definitely, if you're not aware of a challenge that's ahead of you, for sure you cannot prepare for it, right? Yeah. So that's what I try to kind of help our customers realize that, okay, guys, this is what it takes to develop an inverter, to DC-DC or power, any power electronics device, and this is what lies ahead. You should get prepared for it, and you're also emphasizing into this that now the product life cycles become like more faster and faster, like shorter time the life cycles. We need, our customers will need to kind of roll out new products, and one maybe enabler of that move fast approach is like simulation at the beginning, a very good systems engineering, because when things get complicated, you always would like to have somebody like a kind of a lighthouse, not to lose your direction. Focus, focus. So simulation and systems engineering is, I think, is a really important part of like developing a complicated system like power electronics in a much faster pace.
For you, what's the most amazing EV technology for you?
So I think it's the
technology on an EV, right? So is it an inverter? Is it an e-axle? Is it a e-motor? Is it the combination? Is it the software? Just for you personally.
For me, I think I'm biased towards e-drive systems. That's what my focus is. That's why I try to kind of learn, apply, discuss with my friends, also experience. So that's why I could say that like e-axles or e-motors. I even kind of started looking at like, okay, maybe we have e-drive systems, or what it takes to have an e-drive on lunar surface, right?
There you go, yeah.
So that's why I think I'm more biased in that sense, but it always, you kind of think that e-machine is like 100-year-old technology, and what would be kind of new thing, that you could, explore, of course, there's a lot going on. So and for example, one interesting maybe information. So when you look at the e-axle, the weight of the e-axle, I think like 40% of maybe maybe 1/3, like 1/3 or 40% of it comes from the e-machine.
From the e-machine.
Yes.
Yeah.
So look at the opportunity to
Sure.
work on it. Like, what would it be like if you just decrease the weight to half, right?
Yeah. Yeah.
And also, since it's one, staying on, let's say, on the traction system, which consumes power to move the vehicle, so it directly affects the range of the vehicle at the end of the day. So, yeah, I would say that this seeing new manufacturing technologies, new design technologies in the e-machine, also adaptations of new technologies in the inverter is definitely an area that I try to explore.
Yeah. So we go back to e-axles for a moment. At AVL, we developed the Hummingbird, right?
Yep.
30,000 RPM. 30,000.
Yep. Yep.
Is there ever going to be an end? I mean, are we going to go to 40,000? Are we going to go to 50,000? Or is there just 30,000? Or maybe, I mean, I've heard somebody the other day asking us, can we test the 40,000, I think, e-motor or RPM or e-axle? Don't remember exactly. But do you see an end there? Or is it just, it's never going to end? We're going to go to whatever, 50,000 or...
There is a clear trend. Okay, so it started like 15,000 or 12,000 RPM, then 15,000, 18,000. Now, 24,000 RPM e-axle is, kind of state,
Expected. Yeah,
By the way, for those who don't know, where the speed is, this is the speed at the output of the e-machine.
Yeah.
Definitely, when you go to the wheel, so it's limited. The speed is limited, and the reason for moving to higher speed at the e-machine side, why bother to go higher speeds, right? Because at the end of the day, you will end up like 500, 600 RPM. Why? Because it's an enabler for the power density. So with the speed that you're achieving at the e-machine output, you have a kind of a flexibility to shrink the size of the e-machine, shrink the size of the gearbox and whole system. So, just think of that. If you could have a really compact e-axle, then it will make some more room for the battery, right?
Sure.
And you could just
less weight, more room, all of that stuff.
Yeah, less weight. So exactly, having less weight. So that's for sure. There's a clear trend, and I don't know if there's an end to it. As long as we can find bearings, as long as we can design the gears for it,
the cooling and all that for it. Yeah.
Why not?
Okay.
Sky's the limit.
Yeah. When it comes to engineering that you're doing, interacting with customers, what is something that you're doing today that you didn't do or didn't have to do 3 years ago? And I'm not talking COVID, I'm not talking video calls versus what we're doing right now face to face.
Yeah, right. There are a couple of things that I've, like my observations as like a kind of a change in the industry. Like there are like a couple of things that I'd like to kind of touch on. So, for example, the components on a car, that was once seen as like a part of the car, is now becoming the driver of the value of the car, right? So that definitely kind of changes the way you work because it puts a focus on a different area than it was before.
And you're talking IC versus the electrified propulsion system today,
and all the kind of subsystems.
Okay.
So, for example, think of the battery, right?
Yeah.
Or think of the e-motor. So it was once like a kind of a thing that you just go and replace, and if it breaks, fine, you just go and buy get it serviced. Now, no, you don't get it serviced. You just the total. If you need to replace the whole battery, it's better to replace the vehicle itself, right? So that's why there's a clear change in the expectations. So that's, I think, driving the expected functionality from the car. So that was just think of the cars that you own maybe like 10 years, 15 years ago. Like there was a kind of an expectation of functionality. You just drive it, maybe you had an expectation for top speed, but nothing more, But now the expected functionality goes beyond like, driving the car. Now you would expect the car to maybe brake before you realize you
need to brake. Yeah.
Exactly. It maybe just helps you to stay in the track, right? Or think of the case that now maybe instead of going to the service, you would expect the car, to warn you that before things get really worse, just tell me that it's going to get worse, so that maybe I pay less for service. That also puts a different focus on where we work, where we spend time. And as I said, for example, this failing was an option before. Like, fail, fine, but not anymore. I guess when you think of the failing, it is now one of the things that you would like to avoid at whatever it takes. Some of the failures you would like to avoid at the cost of whatever it takes. So that's why we have concepts like functional safety, or there are efforts that we put in, like or safety of the intended functionality, right? There's now more focus on the validation, or the way we validate the things. So that's why maybe that's a kind of another change. And also, when you look at the development process, so once we had quality gateways during the development process, now we have additional function-based gateways. Like we say, because the vehicle became so much function-driven that we had to kind of think of these gateways. Guys, we need to make sure that we are in the right track. We are developing with the expected pace and with the expected function. So to be able to kind of move along with that target, so we now have this function-made gateways. I think all of these kind of shifts in the industry, the way you work or the targets that you work for, has implications in any area right now.
So for batteries, one of the big concerns is thermal propagation.
Right.
What is one of the biggest concerns outside of the battery with an e-motor, an e-axle, a DC-DC, a onboard charger, or an inverter?
Right.
Is it the same? I think cooling certainly is important for all of them. But is that the main concern, like we have with batteries, about a thermal runaway, for example?
There are a couple of things. So, for example, well-known unintended acceleration case is mainly driven by the inverter and e-machine. So,
true.
That's one of the things that we would like to make sure that we do not, generate torque at the e-machine without the consent of the driver. So it should be the output of the system should be along with the expectation of the driver. It doesn't have to be like out of control. Even like slightly higher acceleration than you did, that will be a problem. That's one thing. So the other thing is that, as I said, failing is not an option anymore. So we would like to keep all these components intact, functional through its lifetime. So that's why now in the inverter there are like circuits and software that tries to avoid short-circuiting the switches. So basically, if you don't put some attention at that, if you don't put it in the design, it's so easy to short-circuit the battery terminals, because basically it's just a matter of like two digital signals going at the same time. Just you say turn on, and the inverter switches will just turn on, and here you are. Like in a fraction of a second, you will have a maybe thermal event happening inside the inverter. Maybe it will have some propagation, going to the battery side. So maybe those are the two things that comes to my mind.
Okay. Yeah. And maybe last question for you: how important do you consider systems engineering? And now I always consider myself more of a systems guy than a component guy. When I talk to other people, the component is important. That's why we have a specification. And ultimately, then these components come together. And there needs to be some integration, but it should or it will work. I've seen lately much more of a demand for systems engineering, but I want to know how you see that.
I think I do more systems engineering than any other, areas.
Okay.
Like I do systems engineering maybe 50% of my time, maybe more.
Yeah, so it's very important then.
Yeah, I think we touched on that at the beginning of the conversation. Like systems engineering is enabler of like fast product development, higher maybe confidence in the design, maybe better or more efficient validation, because systems engineering has a kind of a role that ensures the integrity of the system. Like it could be functional integrity, it could be physical integrity, all the other things, like thermal integrity, everything. It all starts with really laying down the foundations during this or with the systems engineering, so that all these teams work on their own, and then they bring their work product together. It has a kind of a consistent, functional, and integrated system. So yeah, that's why systems engineering is, I think, becoming more and more important.
You think it is more important for EVs at this stage of the technology, let's call it evolution, than it is or was, let's say, 20 years ago for traditional powertrain?
I would say so. So basically, my previous experience was with a company in the defense industry. That was a very important topic at that time. But now I think it's becoming more and ever. One maybe reason is that since EV is like an area that we all explore, right? So
exactly.
there are a lot of unknowns and maybe challenges ahead. Maybe we don't know how to tackle them. That's where systems engineering is like, I guess, you know. Even if there's another solution, at least we should be aware of it. Then maybe we go and look for maybe kind of a solution, maybe look partnerships. So whatever it takes, we have to. I think systems engineering plays that critical role, that standing in the middle and saying that, guys, you know, maybe this is a kind of a requirement that comes from other side of this, like another system, but it will have implications on it. Be aware, right? So I think, you know, we have colleagues working on this kind of traceability of requirements, traceability of, for example, validation. These all become like a role of systems engineering, and you know, that's why I'm more and more spending time in this area.
Thank you for your attention. Hopefully it was, again, very beneficial, very insightful, and certainly Ilker, an expert in his field, hopefully provided a good directions here. Thank you very much.
Thank you.